Okay, welcome back. So for today, we're going to cover data structures. Before I get into the lecture, I wanted to point out here, I already posted step 1 here on the website. I also posted on Canvas. So what I want you to do is to go over the lab exercise. And here I also posted the lab submission instructions. So I recorded the video 10 minutes yesterday, and I will encourage you to watch it, okay? For all the labs exercise submissions, all I need is just a link to your Google Colab notebook, okay? And everything you need to do is in that video. I'm not going to talk about in the lecture today. So just watch the video, do the lab assignment, watch the video, get the URL, submit to Canvas, and all the visual assignment will be doing the same way. So make sure that you watch the video. And so in terms of lab assignments, I think roughly every lab assignment will have the 10 questions. So I can give you an overall right now. So for the Python basics, for roughly every 2 lectures, we are going to have 1 lab assignment. So this would be, for example, 2 and 3 would be lab 1, 4 and 5 would be lab 2, and then 6 and 7 will be lab 3. So these will be 3 lab assignments covering the Python basics. And then we have 7 other assignments covering just the Python geospatial packages. And then for the last couple of those, we may not have lab assignments, but it's some extra information for you to start thinking about your final project, okay? So right now you have no idea what to do. Don't worry, it's perfectly fine. You will figure it out later. And it's very flexible. Think about some of the GIS or remote sensing courses that you have taken. Probably in the past you use some desktop GIS, QGIS, ArcGIS, do some of the data processing. And by that time you will understand, like, can I use some of these programming skills to automate the process, make your life easier? If you have in the past ever done some very repeated tasks that you clicked the button and then so many times and then you think that there must be a better way. This is so stupid, like I have to click so many times, or I have to manually open the file or do things like again and again. Then yeah, programming can help you. And so again, well, we'll talk about more later this semester, but right now I'm just giving overall. There will be 3 lab assignments about the Python basics, and then will be 7 assignments more about those geospatial data visualization and also analysis. And that's it. So again, follow instructions and then submit the lab assignments. So lab 1 covers variables and data types and also data structure. So for today, we're going to talk about data structure. And last lecture, we did talk about data types. And today, actually, there's some overlap with the last lecture, but that's perfectly fine. As beginners, I want to reiterate some of those concepts. So because these are all the building blocks. So the data structure is more like a composite data type. So last time we talked about data types, right? What kind of data types have we utilized Python in the last lecture? What data types? Strings, float, int, Boolean, yes. And we talk about some composite one, right? We briefly talk about list and dictionary. So today we're going to cover a little bit more. And again, make sure you understand, because these are the building blocks. These are just the Lego building blocks. Without understanding these data structures, there's not really much you can do, because most of the geospatial data is being stored in some of these formats, and you need to know how to retrieve the data, how to manipulate the data, how to save the data. And so I'm going to show you here again. You can open in Google Colab, or you can go to the Git repository in here. So everything's in here. I'm going to show you the reason why we use Git is because you don't need to download again and again. So if you remember correctly, in the last lecture, I used VS Code, right, to clone the repository to my computer. So anytime if I updated the repository, you can put it one more, just put it. So I'm going to show you how you're going to do this. So for example, I'm going to open website VS Code. So I'm going to open this one, and then you can open the folder, and then there will be a button for you to just put the latest changes. So I'm going to show you in here. Let me close this one, and then close this. Save. So this is the repository that I clone, right? So you see the home page in here, clone git repository. This is what we did last time. So now, if you, I think it's spinning, but on the left side here, this one we're showing up. See, on the lower left corner, it's still spinning. But eventually, it's going to show you can pull the changes. So one thing you can do is to make sure that your the local repository is synchronized with my remote repository. So right now, I want you to pay attention to here, lower left corner here. Lower left corner here, do you see something? Main, and then there's more like an icon like the circle, and then there's one, the down, right? The down arrow, and then another one, 0, up arrow. So that means right now, if there's a down arrow, that means you are behind the repository, behind. So I can show you what's the differences. So in the Git repository, if you go to my GitHub, right? So you can look at this one right now, I have 48 commits. So I probably make some changes yesterday. If you see this one, right, submission video, blah, blah, something like that. So this is the new one, and you don't need to re-download them. All you need is just to click that button, it will synchronize. So how can you verify that it's the latest one? So if you go to on the left side here, there should be a source control. And then under here, you should be able to see the commit history. And look at this one, right? Visualize incoming changes, and this is the update collab, right? So this is the latest one on my computer, but on Git on the website, look at this one, right? Update collab. So you're missing this one. So this is where Git is very useful because it can so-called Git pull the changes, and then you are synchronized with the GitHub. So again, I'm going to go back to VS Code here. So all we need to do is just pay attention to this one. So every week, I'm going to add a new lecture, and you don't need to re-download the file again and again. Once you clone, and every time we open, just click this button. So pay attention to what's going to do it in here on the left side. So I'm going to click this button, and within a couple of seconds, you should see this one. See? Original, update. So now your local repository is synchronized with, basically you're always getting the latest version that what I publish on GitHub. So this is the power of Git. This avoid downloading the file again and again. You will only pull the difference. So the local file is still the same. So right now, if I go to my, for example, book, and then labs, and then if you go to the lab instruction, right? So you see here, this is actually the video that I edited yesterday from GitHub. So now you're getting basically the latest copy. So all you need to do is to follow the instruction, synchronize, and then you always get the latest one. Git is not the focus of this course, so I don't teach you how to use it. But this is the only use case that to get the content, get the course materials from GitHub with just one click. Questions? Yes? Lower left corner here, lower left, and then there should be like synchronize this button, like the circle. Or you can also go to here on the left source control, no, on the left side here, this one, and then there's a 3 dots here. You can also click this one, Git pull. Pull means you're pulling the changes to locally. So either way is fine. It's up to you. Or I can also use the local version. I can use the terminal. So if I click this button in here, and I can open the terminal. Again, it's not required, but I usually use the terminal if I don't want to use the interface. So here you can just type Git pull. You also put the changes. Right now it says, okay, everything is up to date. So there's not really anything you need to do. But whenever I update things, you just type Git pull, you will download the latest version. Make sense? The only thing that sometimes you might encounter is if you're running, for example, the notebook locally, and then it's going to showing up, okay, you have changed the file, blah, blah, blah. Then it's going to have conflict. Then you need to cancel your local changes in order to be able to do that. So what I can do here, for example, I'm going to go to this file, and then if you mess around, for example, if you don't like the stuff that I put in here, you delete my stuff, okay? And then Control S. On the left side here, it's going to showing up, okay, you have a file that has changed. You cannot push this one back to my repo. You don't have the admin right. But what I'm saying is, if I also make changes to this file, so when you're doing the Git pull, it's going to show you some errors. Right now, there's nothing going on here. So what you can do is just to come here, Right now I only have one file, but you might have multiple. So just hover your mouse to these changes, and then just click this button. Basically, discard all the changes. So that means right now your repo is clean, and then you can pull the changes. Make sense? You will notice that when you're trying to pull the changes, it says, okay, there's error, you need to commit first, blah, blah. That means you are changing the file, I'm changing the file, there's some conflict, it doesn't allow you to do that. Then, yeah, just remove all your local changes. So click this button, and then discard. Then your repo is synchronized with my upstream. Then just git pull. That's it. You see right now, say blah blah. Git was fetch git pull. You see, it's fine now. And again, if you want to learn more, there are tons of YouTube video. My YouTube channel also have Git for another course. But here are some of the instructions if you want to see that. But for this course, all you need is just Git pull. That's it. To pull the changes from the repo to here. All right, so that's about Git and also the lab assignments. So next, let's get into the lecture about data structures. And so let me close this one, open Python, and then data structures. So again, you can follow using the Google Colab, or you can use VS Code, whichever you prefer. So data structure basically is how the data being stored, how you manipulate the data, how you access the data. And so specifically for this lecture, we're going to cover 4 different types, okay? Tuple, list, sets, and dictionaries. So those are the 4 primary data structures in Python. And this is called composite data structure. That means you can, so previously we talked about integer, right? Float, strings, Boolean. So those are more like just the primary type. It's just single one, but we can create composite data structure that include any of those types that we have covered. And then we want to talk about how to access the data, right? So if you have a list, for example, I can have a list storing all the names of all the students enrolled in this class, and I need to print out all their first name. So for example, you have first name, last name, right? Stored in a spreadsheet, and I need to just get the first name, right? How do I do that? I'm not going to do that manually. Just copy paste, copy paste. I can just write one single line of code. I can print out the first name easily. And it doesn't matter is how many students. It can be 1 student, 10, 100, 1,000. It's the same line of code. It doesn't matter how many you have. So all I need to figure out is how do I do the looping. So we're going to talk about some of those. So the first one here, we're going to talk about tuple. So what exactly is tuple? Have you heard about tuple? Not so much, right? This is only in programming language. So tuple is so-called immutable. Immutable means once it's created, you cannot change it. Okay, and there are cases sometimes like this that you don't want the user to mess up the program. You only once it's created, you cannot make changes. So this can be useful. For example, you have a program you don't want it to change. You don't want the hackers to hack your program. Then you have something like immutable. You cannot update it. You cannot make changes. So tuple looks like something like this, with wrapped with parentheses. And again, make sure you understand this one. Right now we have multiple lines. It's the same as single line. So if they only have 2 numbers, you probably want to basically just define something like this. It's perfectly fine if you want to have two lines, and you can remove the comma. So the same like this one. So we have a tuple with 2 numbers inside. So pretty much all the things we're doing here, the 4 data types, tuple, this, dictionary, and set, they are all separated by the data elements within the data is separated by comma. Okay, so you're going to have a comma, for example, tuple, a number, comma, and then a list. Also keep in mind, this data structure, we can store anything. Or tuple can store numbers, it can store strings, it can store true and false Boolean, it can store anything. So it's just like a composite data type. Right now, what I'm showing here is just like a point equal to this one and this latitude and longitude, right? And you can just run it. I will select the kernel. So now this one is stored in the memory, and you can print it out, right? You just type point. Simple as this, you're going to print out this one. So this one you cannot make any changes, but you can access the elements. So in Python, all the lists or tuple or dictionary, they are all being accessed by the square brackets. Okay, so everything in the dictionary in the tuple, there's an index. So for Python, all the index start from 0. Okay, so index 0 means it's the first element. Index 1 is the second element. Okay, so it start from 0, and make sure that some languages start with 1. Okay, so you need to pay attention. Most program languages for the indexing, it start from 0. So in this case, right, we have a point with 2 elements. So if I want to get the first one, then it will be point square bracket 0. If you want to access the second one, then it will be point 1. Make sense? And then after that, you can print things out. We also have the so-called F string here. F string is something that can be useful if you need to print out something and then you want to have some placeholder inside. So this is useful for printing things. For example, latitude, and then you have square brackets. Then you put the name of the variable inside. So basically, this one here is the placeholder. So when I'm printing, I'm going to print the text, and whenever it encounters the the curly brackets, and this is the variable name, it's going to grab the value of that variable, right? So this is going to print out, for example, the latitude, because latitude is equal to this first variable, the point 0, index 0, and the longitude this one. So make sure that you understand how to use this one. You can just print out any variable within a long string, and then have the placeholder inside. For the next lecture, we're going to cover, for example, another one called format. It's the same thing, but this one right now is the preferred one. Okay, so F string means placeholder for variables, wrapped with square brackets. And this one here, this not square brackets, curly brackets. The curly bracket itself is not printed out. Understand? So in here, right now I don't have the curly brackets in here. You see latitude and then just the number. So the curly brackets indicate inside the curly brackets there's a variable. Print out the value of that variable. Make sense? So this is the point. And how about this, right? So we only have 2 elements, right? You can just point and then 0. And then this is the latitude. Point 1 is the longitude. Can I do point 2? Yes or no? No. Tuple index out of range, right? So you only have 2 elements. Your index will be 0 and 1. Okay. How about this? Point -1. Will that work? Why? Yeah, goes backward. So -1 means the last one. -2 means the second last one. So you can go backward. So the reason why you want to use negative is sometimes you might have a list like has 100 items. You don't want to count like 1, 2, 3, 4, 5. You can just use, if you're getting the last one, for example, or like we have 10 students. I want to order you guys alphabetically by last name. Okay. Okay. Who is the first one? Who is the last one? Then you can have 0, -1. Then you get the number. So you don't really need to know how many students in there, right? So you can use -1. Then you're going to get the longitude. How about -2? Can you do that? Yes or no? Okay. -1, -2. Yes. Going backward. How about -3? Can you do that? No. Out of range. So start from 0, 1, 2, 3, whatever, and then -1, -2, -3. So you can go either forward or going backward. And this is also applies to list. Okay. You can also index by positive number and negative number. Okay, so this is about tuple. Again, try it out, but you cannot make changes. So for example, here, I can say the first one, right? You can get the value, but if you're trying to assign a new value, then it's going to be problematic. For example, 35, I want to apply like assign 36. Boom, said tuple object does not support item assignment. That means once the tuple is created, it's a done deal. You cannot make changes. So tuple is pretty simple. Parentheses, separated by comma. Inside you can put whatever you want. It doesn't have to be numbers. It can be string. For example, I can say cities, okay, equal to parentheses and then double quote. For example, Knoxville, okay, and maybe New York. Will it work? Yes or no? Can I do this? Of course, it can be anything. So the elements can be any data type. It can be string, it can be number, it can be Boolean, it can be all kinds of things. And again, I can cities, and then indexing 0, right? You can get whatever you want. You can also have the other one, for example, conditions equal to tuple. I can have true, false. It's work as well. So it can be anything. It can be a tuple within a tuple. Right? If it's something you want, it can certainly doable. So for example, it can be like this. I have cities, and then inside here I can have like right. So how about this? Will it work? Of course. Now I'm going to show you something like this. So let me ask you a question. How do I extract New York from this variable? Think about it. Maybe let me add another one. So just to be more obvious, okay? I can see Knoxville, New York, maybe in Nashville, and Chicago. Okay. So how about this? How do I get Chicago? Extract Chicago from this variable. Can we do that? So everything stored in that variable is some kind of information. So if you need to get that information, you need to do the indexing. So think about here for a second. How do I get to that, right? Need to look into like nested, so you can do nested extraction. If you don't know how to do that, think about the outside first, right? Don't look into the inside. So how many elements? Let me ask the question. How many elements in this variable? In this tuple? The upper level one, right? How many inside? How many? 2? They can try it out, for example, right? Cities. And we can just do a testing. 0. Okay. And 1. Can I do 2? Yes or no? No. Because it is only 2. So you look at the bigger one, the outside parentheses. Because in here, we have a tuple, we have nested tuple. So this one is treated as a single one, a single element. And that element has not 2 elements, it doesn't matter. But outside, you only have 2 elements, right? 2 parentheses separated by comma, so you only have 2. And in order to extract, for example, Chicago out of those, right, we need index 1, right? And then this element is a nested tuple. So how do I get to Chicago? It's a tuple, right? How many elements in this tuple? 2, right? So what do we do to get to New York, to Chicago? Another bracket, another 1. So you can nest it, you can index it, you can make more complicated. You can 3 nest it inside. You can go deeper, but think about the big picture. Forget about the nested structures inside. Look at the out of the box, right? So if you have these parentheses, you look for the one at the end. So right now, if I have on my mouse, doesn't really show you that. So if you look at this one, look at my cursor at the beginning, right? I put my cursor at the beginning of this yellow parentheses. Do you see another one is being highlighted at the end, right? So that means this is the outside one. So right now, if I hover my mouse in here, you see the other one is being highlighted. So basically, when you highlight this one, this is a tuple. You look for the comma of any composite item. So this one is treated as 1. This will be index 0. This will be index 1. And then this will be index 0. This will be index 1, 0, and 1 for each individual item. Okay, so I can extract Chicago by 1, 1. How do I extract New York? 0, 1. Good. 0, 1. So on and so forth. So you can have a nested data structure. And again, this is the same, just like a list, a tuple. You can do the same thing. So there's nested list, there's nested tuple, there's nested a lot of things in Python. So now you know how to access that. Is there another way to access New York besides 0 and 1? Can you come up with another one that can also extract this one, extract New York besides 0 and 1? How about going backward? Negative 2, and then negative 1. Good. All right, so you can go backward, right? From the negative 1, negative 2, and then going backward will be negative 1. So New York will be negative 1. So this is how you create the tuple and also access the tuple. So next, let's talk about list. This is pretty much the same as tuple, except it's mutable. That means you can make changes. So earlier I mentioned they have different use case. Tuple is something you don't want them to change. This is something you want them to change. And the only difference is like this is wrapped by square brackets, not by parentheses. So same thing in here right now. I have a list. Within there, I have 3 tuples. Again, it can be a list of tuples, list of this, list of this, of this, of this, list of tuples of this, of tuple. It can be any composite. It can be any combination. So there's no specific rule that you cannot do that. But you want to try to avoid too many nested structures so that it gets very confusing when you're trying to access the data. So right now, for example, this is a path variable. We have 3 points inside, so kind of like a line. And once you define this one, list, because you can allow you to change, that means you can append something. So before you try to figure out, for example, what things inside, what you can do is just type the path variable and then dot. Then it should pop up the list of methods that are available for you to apply. So this is the point of object, so-called object-oriented language. Object-oriented means everything is an object. You can do that object can do something. They can also have the so-called a method, a function, a class, or something like that. So just like each of you individually, right? For you, you can have some so-called properties, or there's some so-called methods, actions. So property means it's something, the characteristics associated with each object. Methods, that means some actions you can take, right? So for you, you have your major, you have your name, you have your social security number, you have your height. So those are things more like just the property, the attribute. But you can also take actions. You can walk, you can speak, you can run. So those are things that attach to that individual object. Same thing in here in Python, right? We define a variable, and this is a list. A list have a bunch of methods you can do, and this is why it's so powerful, because you can take actions. Right? So look at the first one, append. So when you hover your mouse, or use a down and up arrow, okay, to select this one, you're able to see like what you can do, right? So a tuple, you can append some, at least you can append something, you can create it, you can copy, you can count, you can add an index, you can extend, you can pop up, you can remove. So there are a bunch of things you can do with a list. And right now, for this example, take a look at this one. I can use the append. That means you can append something to a list. You can also hover your mouse somewhere in here, for example, and then just run it. So right now, you see these right now have 4 elements. So each element has different tuples inside. So this is how you can manipulate a list. How do we figure out how many items in this list? You can count manually, right? 1, 2, 3, 4. But in programming, you don't want to do hard coding, okay? You don't want to manually say that the count equal to 4. You always use a function, because in that way you don't need to make changes. So there's a function that you do need to use like from time to time. It's called len. Len means length. How many items in a list, in a tuple, in a dictionary. It can be many data types. So in here, what you need to do is pass in this variable and then just run it. Okay? 4 elements. Make sense? So how about this? I'm going to go back to my previous code block. And I'm going to click this one again. So right now, if I run this line, how many you want to get? 5. Now you see the difference, right? I don't need to change this line. But if you hard code it in your source code saying that it's 4, then you need to change 2 lines. Right now, I don't need to change because the function is going to get the result based on the variable. It can continue to run 1, 2, 3, 4, whatever. It's going to change, update it automatically. Right? So this is how you can modify a list. And how about this? I'm going to add another code block, and I'm going to say pass dot clear. As you may imagine, what does this one do? So always for all the methods, you need to end with parentheses. Okay, don't just type something clear, and it's going to show you a function list of something. If I run this one, what are you going to get? What are you going to get? Q7, because you're not actually calling. Like I mentioned, right now you're just accessing the function, but you're not actually calling the function. In order to call it, you need to have the parentheses. This is really calling the function. So right now, if I run this one again, doesn't say anything, but if you run this one, you're going to get 0 because all the lists have been clear. Right now, the item right now inside doesn't have anything. So if I type pass, see, it's empty. Empty square brackets, that means it's an empty list. There's nothing inside. So I'm going to go back to this variable here and run this one again. And right now, if I run it, you're going to see you have 4 points. Length of 4. Okay. So this is how you can define a list. Next, let's talk about indexing. So list indexing in Python is very important. So we talk about the tuple indexing, right? 0, 1, 2, 3. But how about like we have these 4 points in here. I want to get the second and the third one. How do we do that? Right? I want to get the second and the third one. How do we get the second one? How do I get the second one? What's the index for the second element? The list. I want to get this one. And then just this one. Oops. How do I get this one? 1. So square bracket is 1, right? Oh, sorry. 0, 1. Yes, we can get this one. How do we get the third one? 2. Okay, can we do both? Can we do it like this? Doesn't. So that means you need to have something else. So in Python, for list slicing, you can have something called colon. So colon means the start and the end. So you can specify the index with a start and the end. So in here, let me show you. Right. So we're going to start, for example, from which index? When we get the second one, the third one, what's the start index for the second one? 1, colon, and then 2. Okay, let's try. It only gets you the second one. So the trick is the start and the end. The end is excluded. N is excluded. So in order to get the third one, you need to increase that number by 1. So you'll be 3. So 1 to 3 means 1, 2, 3 is not included. So in this way, you get 2 items, the list. Okay, and you can also ignore it. So for example, let's say you have 4 items in the list. I want the last 3, or I want the first 3, or I want the second or third, whatever. You can do the colon. So what if you skip that? It's going to, for example, start with the second one all the way to the end. So for example, here I can remove this one. So 1 colon and then empty. That means okay, start with index 1. So 0, 1. Take the rest. Okay, so this one you will be getting 3 items. So you'll be getting these 3 here. How about I want the first 2? Well, we need to change in here. colon 2 here, like this. No one. Okay, 2 point. Right. So empty 2. That means 0, 1, 2. 2 is not included. Okay. Always remember the ending index is not included. How about I want to get all the elements? That might sound a weird question. Why do you need to get all the elements? Can we get all the elements? What do we need to do? Yeah, you don't need to do anything. You just put a colon inside. You will get all the elements. So from the beginning to the end, it doesn't matter. So you basically get this is the copy of the list. So this way, sometimes if you need to copy a list, this is actually what's being used to copy a list. So you don't modify the original one. Because if you otherwise if you change things, you're going to change your original one. So list is mutable, and it's also referenced by value in the memory will also be changed. So if you change the value, you're going to change. If sometimes you're going to make a copy before you mess up something, this is the way to keep a copy of this. So indexing 0 or whatever start to the end, and second, the end index is not included. So besides this one, like earlier we start from beginning to the end, right? The 0, 1, 2. How about we count backward? I want to get the last 2 elements. So how do we use the backward indexing? What should we be doing here? Going from the back to the thing. Negative what? 3? 3 or 2? But the end index I can keep it is empty. So look at this one. Negative 2. So that means, right, negative 2 right now is the start indexing, right? So you think about here, we have 4 elements, right? Negative 1, negative 2, right? So it's a start with this one, negative 2, and then all the way to the end. You'll be going to negative 1. It doesn't matter. You will take the rest of that. So if I need to take the last 3 elements, then you'll be this. Oops. Negative 3, and then colon, and run this one. So this sometimes might be very confusing. Like if you start from the beginning, it's 0. If you start from the end, it's negative 1, right? But always remember, if it's the start, that one is included, the start index, the ending index is not included. So if you skip that, it's going to get all the way to the end. The beginning, if you skip it, it's going to get all the way, and then 1 minus this index minus 1, the ending index minus 1. Just practice it. You will figure it out. You understand, like, when do you need to add 1, when do you need just to use negative numbers. So it's very common. So you're going to have some examples how to do the indexing. I can give you a very complicated complicated examples how to do the indexing. For example, here right now, look at this, a pass, and then you have something like this inside. How about this? Let me another one here, pass dot. Of course, it doesn't really make sense. You should not really do it this way, but I'm just going to show you here. I can have this one, for example, Knoxville. And another one, pass dot append. Oops. And I can give you a number, for example, 1000. Or maybe like this. I'm going to give a list, and then inside I'm going to have city. Okay. And I'm going to state. And I'm going to maybe have Knox County. Whatever. Pass. So right now this is a list, right? It's very complicated. It has tuples, have strings, have a list inside, and a list of something. So let me ask the question. How do I extract Knox County from this? How do I extract Knox County from this variable? Can we do that? Pass? 5 2. Good. You're good. So you need to count from 1 to 5. How about if I have 100 items? Probably if it's very long, you want to go backward, right? Going from maybe 25 to negative what? Negative 1, right? Because it's the last item. Oops, sorry, negative 1. I cannot count. How can I extract nodes without counting? No? You see, this is a string. Any string is also a list. So you can treat this string as a list. You can also use indexing. Get nodes out of this string. So all you need to do is to add something at the end. Another bracket. So what's nodes, right? 0. If it's 0, you don't need to type it. You can just skip it. And I'm going to have a colon. So what do you think? What should be the number in here? How many characters nodes has? So think about here, right? 0, 1, 2, 3, 4. It's quite confusing, but this is the way that you can get all the way down. If the least, you can get all the way to the end. Right? How about how do we get county? I don't want nodes. I just want county. What do we need to change? So what should we be doing in here? So county, right, is the last word, right? You don't really care about what it is. So how many characters in county? 5, right? So it should be negative. Negative 5. Oops. All right. So the start negative 5, negative 1, negative 2, negative 3, 4, 5. You should have negative 6. This is rather confusing. But the easier way would be like this. So let me show you. You don't need to count how many. Because this is a string. So there's a function. If you type dot and then split. So there's a split function. You can split a string by space, by comma, by anything. So what I can do is just like this. I don't care about how many is in there. As long as the space inside, I can just use the split function to split the string. And this is actually useful. I can split the first name and last name. I can get all the last name because you're going to have a spacing in between. And you can get them all at once. Right? So if I have 10 students, as long as I know how to do that for 1 student, it doesn't matter how many students I have. It's going to be the same, just a loop at least. We'll talk about that in the next lecture. But this is certainly something you need to practice, get an idea like why are we doing this. So it's nested, nested, nested. Once you extract the things out of that, becomes an element. That thing is an object. That object always going to have a method. You just type dot, and then you will pop out a list, and then you can start applying something else. So this is, you can basically apply a chain of options, actions into that element. Make sense? So this is about the list, and you can print out. Next one is about a set. Okay, a set is like also very similar to a list, except that there's no duplicate items. The list. So think about it's like unique elements. The list. So for example, right now, if I want to try to figure out the final letter grade, right? You may get A, B, C, D, E, F, right? Somebody might all get A. But if I want to count how many A in the class, how many B's, how many C's, right? You not a good case. Unique element means, for example, all the students here, and I'm working at a university, I need to figure out where are the students coming from how many continents, from how many countries, right? And then on the advertisement, you can say, oh, a student coming from 129 countries around the globe. How do they know? Because each student is going to have a profile. They're going to have a country, right? If you're all from US, I just need one US. I don't need so many US, right? Come from Canada, you another one. So this is where set is useful if you just need the unique elements. So you're going to basically reduce all the duplicate as one, rather than you have to do that manually. So look at this one, right? I'm gonna have a list, and I have these three elements. So North America, Europe, Asia, and all we need to do is to turn this list into a set. Okay, so you define a list first, and then you just set parentheses. Then you put in the list. Then you will create a so-called a set. So look at this one, and then you can just print it out, right? Regions. So right now you see it becomes a set with curly brackets in here. How about if I add this one, Asia, and then another Asia, another country, another continent in here. So right now this list has 4 elements, right? If I run this one, if I run again, will you see any difference? No, it's still the same because it removed the duplicates. So you can have as many duplicates as you want in the list. It's going to remove them. So it's give you the unique elements in the list. Again, this is very useful if you need to find out how many unique elements. So for example, right, if you're working in the let's say in the Census Bureau, you're trying to figure out what are the unique first name, what are the unique last name, for example, or what are the unique countries. So this is something useful. So you can add as many as you want and become a set. You can also add another one inside. For example, regions don't add, right? So over here, once you have that variable, again, just type dot. You will know like what kind of things you can have add, you can have append, you can have clear, you can count, index. So there are a bunch of other methods. So for all the lab assignments, if you don't know what to do, just type the variable and then dot and then see what guess what you want. Oh, by the way, so for the lab assignments, my suggestion would be just do it on your own. Don't dump the questions into ChatGPT, okay? You can certainly do that. It's hard for me to figure out. But as a beginner, you should practice. Once you understand, once those things become your stuff, then once you know how to do the stuff, it's okay to use those AI stuff. At the beginning stage, you need to think, practice. And if you have any questions, if you're struggling, you can post questions on GitHub. If you're really struggling, you don't know what to do at the end, you can ask ChatGPT like, question, give me the answer, it will give you. But again, you need to make sure that you practice enough before you rely too much on the technology. For me, I use ChatGPT every day, every hour, but I already know the stuff, so I can quickly utilize it to make some improvement. But for you right now, I will not recommend. Okay, so do really spend some time. If you think it's too time consuming, talk to me. I can give you a little bit more reading to improve. But we have been practicing a lot in class. You should also practice after class. So the free credit, you should practice 3 hours. No, not 3 hours, 9 hours. Okay, outside the class, doing assignment, practicing, watching video, reading materials. So if you didn't spend any time outside class practicing, you're not going to really learn the stuff. So programming is learned by practicing. So do really spend time, and once you reach a certain stage, then you can use ChatGPT to improve your productivity. Beginners, I would not recommend. It's kind of like you are a baby right now, and the baby is watching those people competing in the Olympics, running very fast, and then just trying to run, you're going to fall down. Okay, it's not surprising. So when you don't have the foundation yet, don't just jump directly to the shortcut, because when we're doing the lab assignment, it's going to become more and more difficult. And right now, this is the basic one. You will be able to find all the answers in ChatGPT. When we do something more like customized geospatial stuff, the code that it provides to you may not work. Then you need to do debugging and fixing the things. And if you don't have the knowledge, if you are missing those foundation building blocks, it's going to take you more time to fix the stuff. And so I just want to warn you that this is not supposed not to be a very hard course, as long as you spend some time practicing. So again, it's up to you, but you have questions, if you have any issues, let me know. Okay, go back to the set, right? And you can append, you can add something. For example, this one I can add an item to that. And if I try to run this one again, can you do that? Can I run this one again? Yeah, it doesn't matter. It's always going to give you the same result, because if the element already exists in the variable, you don't need, you can add it, but it's not going to change anything, right? So how about this Africa? I can use maybe Australia, right? And if I run again, I'm going to add Australia. But once it's added, it's going to be there all the time, right? So if you're trying to add Europe, doesn't matter because it's already there. Also, for this, all these things, you can convert different data type back and forth. Right now, this is a set. So for example, I can just type this one, type regions. I'm going to tell you it's a set. But we can actually turn it back into a list if you want to. So here I can say regions is equal to. So how do I turn this one into a list? It's like this, list, regions. Okay. So you want to turn something into a list, you have a list. You can turn something into a tuple. You're going to like tuple and then parentheses. So you can run this one, get this one, oops. Regions list. So do you notice the difference? So right now we have this. And so for this time, if I use the regions list dot append and parentheses, I can have another Asia. Oops. Can I do that? Will I change the value of the regions list? Yes or no? Yes, because now this is the list. So you see, region list. You see, you can have duplicate things inside. It doesn't matter. So right now my question is, how do I remove the duplicates in this list? What's the easiest way? Say it again. Yeah, make a set. So it'd be like set regions list. And you can assign to a new variable if you want to, but okay, it'll remove the duplicate. So you can convert a set to a list to a set if you need to remove the duplicate. But if you need to make some changes, you need to add some duplicates, then you convert to a list, and then you can start doing append, you can clear, you can copy, you can do all kind of things. So this is some of the very common data manipulations. Okay, so this about set. The last one, dictionary. This one is also super useful. Dictionary is something you're going to encounter all the time if you're dealing with geospatial data. If spatial something so-called GeoJSON or JSON file, it's always going to be a dictionary. And inside the dictionary, you can have key, you can have nested structure, nested. And this is also very commonly used if you need to sometimes get some data out of a database. You need to have a key and you have a value. If that value can be a key and value, so you can have a nested like hierarchy data structure. So maybe let me show you, see if I can find some examples where you can really experience it. Why do we need some of this? So I'm going to go to maybe my GitHub repository here, and I'm going to find some examples. Open Geospatial, and how about I find some data sets here? Data set. And in the second half, I'm going to talk about geospatial data, but for now, I just want to give you some basic, for example, what the geospatial data look like. So I can go to maybe the US, and then I'm going to go to the maybe the US cities. Yeah, maybe this one, US cities, GeoJSON, okay? So when I open it up, it's going to ask you to download this one. I can download it, and I can just take a look what it looks like. So I've downloaded this one to my computer. Then I'm going to open using VS Code. Oh, did I download to the correct folder? US cities, GeoJSON, and Yeah, document, not the one I download here. Book, Python. So I'm going to download this one to my local computer. Then I can open it up just to show you what it looks like. So the book, Python. And look at this one, right? I have the US cities. Look at this huge file. And what you notice at the beginning, there's a curly brackets in here, right? And I can actually collapse them. Inside here, you can also collapse, right? So this is more like the outside. Have the square brackets, no square, curly brackets. So this is actually a dictionary. And then within a dictionary, you're going to have a key, have a value, separated by comma, key, value, separated by comma, key, value, key, value. And that value inside, you can also have a nested structure, okay? But key and that value can be anything. That value can be a list, can be a string, can be a number, can be a list. And within the list, you can have a list of dictionary. And then within a dictionary, you can have a dictionary of dictionary. See how complicated it becomes. It's a hierarchy. But this is actually how it's being organized, for example, in a so-called GeoJSON or in a swap file. So this is essentially, if you open this one in ArcGIS, QGIS, it's a swap file, and you can open an attribute table. So this is how the data is being organized. And dictionary is probably one of the most important data structures for dealing with geospatial data because you want to encounter this one all the time. So we're going to cover this dictionary here just to make sure that you understand how to create one and how to access the data from the dictionary. So I'm going to go back to the notebook in here. And so this is how you create a dictionary. Again, dictionary is wrapped by curly brackets, okay? Tuple is by what? What characters do you use to create a tuple? Parentheses, list, square brackets, and then dictionary, curly brackets. So don't get confused because beginners, you might get confused, but make sure that when you see this one, that means it's a dictionary. So inside, you're going to have comma, and then comma. So this one, for example, name, Tokyo, population, and then coordinates. So key and value. So usually the key usually is a string. It's just like unique identifier. And then the value, so basically key and value pair. The value can be anything, okay? String, integer, float, list, dictionary. It can be a bunch of other things. So right now we define the dictionary, right? Then you can print things out. For example, cities attribute. And it will show you something like this. So a dictionary is mutable. That means you can change things. So for example, right now you say the population is like 13 million, blah, blah, something like that. Assume this is older in 2010. So right now, the population has increased. Need to update the population. Can we? So how do we access the population? We have the variable. And how do we access the population number? So similar to the indexing, similar to the list indexing. So this one here is the same thing. Use the square brackets. And within there, all you need is just double quotes and then passing the key. So if I want to see the name, you'll be name, like Tokyo. You need to see the population. You access the population. Make sure that the key already exists. So if sometimes you have a typo, for example, population 2, can you do that? No. The key doesn't exist. It says key error, that means the key doesn't exist. That's why it doesn't work. So make sure that when you're accessing the data, you need to have that available. And so now let's take a look at this one, population. I need to update the population. Then it's basically just like this, equal to whatever you want. So for example, 14 million. Okay, run it. It's going to update. So you will not print out anything. So in Python, if you want to print out anything, you need to use the print function or you print out the variable. But anytime if you see something equal to something, this is called assignment. Assignment will not print out anything. It's just like assigned to something, change something in the memory. So right now, if I print out this one again, see, is the population being updated? Yes. So right now it's 14 million. So you can update anything. You can update pretty much. Can I update the coordinates? What's the data type of the coordinates? Let's assume that the coordinates is wrong. I need to update the coordinates. Can I update it? It's a tuple. Cannot update the elements of tuple, but you can replace the whole tuple. Right, so I can have another one, for example, equal to, and then the tuple, for example, 40, 30, whatever, negative 100, then it's fine. I can just print out again. You can replace the whole coordinates. It's okay, but you cannot replace just one. You just copy that and then paste and then just change one. That's fine, but you cannot do it this way. You cannot do it like coordinates and then square brackets 0. Then it will not work because that element is a tuple. You cannot change it. So you cannot do this like, for example, equal to 40. It will not allow you because you're accessing the individual element. But if you replace all of them, you can do that. Similarly here, you can print out the object. You can do all kind of things, right? So Tokyo population, blah blah, and also for the list, for example, once you have the city name, I can update it. For example, the name, let's say it's called Tokyo. I don't like the uppercase. I just want the lowercase. Okay, and we update it to lowercase. You can do it like this, right? Equal to what? Tokyo, right? And it should be updated. But usually you don't want to hard code it, okay? I think in the lab assignment there is one example. How do I change to uppercase? How do I change to lowercase? How do I change? So what you can do is like this. I can access this value and then name and then equal to. You can do the same thing, cities attribute, and then name dot. So you are trying to override the value. So you need to get the values first and then do something and then override it. So right now, for example, I need to change the Tokyo to all uppercase. Don't try to like the value equal. You want to basically minimize the line of code that you need to change. If later on you change the variable content. So for this case, if you need to change the uppercase, the better way will be just type upper parentheses. Make sense? It can be upper, it can be lower, it can be title, something like that. So if I run this one, and then cities attribute, take a look. Uppercase now. Yes. You can also do lowercase. I think there's also one like title. Believe so. Title. Right. Change it to this. So everything inside a dictionary can be changed if the some data structure is list, not a tuple, or it can be a string, it can be a number, everything can be changed. But if it is a tuple, then you need to replace the whole tuple. You cannot change a single element in the tuple. So this is about the list, and you can have a list of lists, you can have a list of lists. It can get, you can have like a dictionary of dictionary of dictionary. And let me see here. I can ask ChatGPT, right? Give me a complicated nested dictionary. I will see how complicated it can get. All right, so once you understand the logic, it doesn't matter. So I'm going to copy this one and let's handle this dictionary to get whatever information we want and see if we can tackle this one. So this is a nested dict. All right, so I have this one. So now I'm asking you, how do I get number 3 out of this list? So let's do it. It's probably too much. So I already executed. So now let me do it above here so it's easier to see. So how do I do that? How do I get the number 3 out of that? step by step, right? Okay, don't be scared. Nothing is really difficult. So what do you think? So you need to get the first one, right? Get the first one here. So how many? Right now, this dictionary, you can actually have this one. This is actually useful. Like level 1, then level 2, level 3, okay, and then level 4, inside level 4. So what you need to do is like, yeah, it's going to be boring, but you can certainly do it. So I'm going to here level 1, okay, and then level 2, right? So see what you get. Oops. Level 1, LVE1, okay. We're getting closer, right? We are almost here. What's the next one? Level 3, okay, step by step, we're getting there. And then after that, oh, we need also level 4. And what else? How do we get to this one? So you have another one here, right? So the next one will be key 3, right? And once you have key 3, what's the next one? Sub key 3. Are we there yet? Oops. No, not this one. Mistype. So sub key 2, okay, not sub key 3. All right, getting closer. I'm the last one. How do you get number 3? It's a list, right? 2, 0, 1, 2, or -2, whichever you like. Boom. It's a little bit tedious, but it doesn't matter how complicated it is. You look in the outside first, and then this is more like a family tree, right? You're gonna trace down all the way, right? Right now, for example, here, you try to find your ancestor like 100 years ago. You trace down, get to your parents get to your grandparents, and you get all the way grandparents. Eventually, you want to trace it back down. So if they need, for example, your grandparents need to find you, they're gonna find your parents, and from your parents to you, so you're gonna all trace the way down. So this is how you do the indexing in list. So just use this as an exercise. For example, how do I get to this one? N value true. Very similar, right? Can you right now? Can you do it? From the top level, go to the second one, the key, until the key value. So you just need to look at the indentation, right? And then from this one, and then come here, this one, and then this one. Anyway, just practice. So this, I will ask you, we can use ChatGPT to give you some example. Give me a complicated nested list. And then you start using that to do some indexing, right? So similarly, give a complicated nested list. Oops. All right, not bad, right? So how do I get, for example, key value 3? How do I get value 3 out of this one? Copy and paste. Maybe this is the last practice we're going to do. So dictionary indexing is actually easier. List indexing is a little bit. List. Oh, anyway, it's missing one. List indexing is a little bit more challenging because you need the number 1, 2, 3. Dictionary, you just need the key, so it doesn't really care about it's 0, 1, 2. Doesn't care about the order, just the key. So right now, I need to ask you, how do I extract this one out of this variable? What's this one? What's the first level indexing? Three? No, it doesn't have three. So here, right, this one, and then comma, this one, this 0, 1, 2. Then it's two elements, right? Three elements. So this will be 2. Make sense? And then from there, you go in one side, right? 0, 1, 2, 3. You see? And then what else? This is still a list, right? 0, 1, 2. Make sense? So you'll be 2. And then from here, it's a dictionary, it's a list. 0, 1. So the key 3 is here, right? So you'll be, what's the indexing? 0, okay? Because it's the first element. And then now it's a dictionary. How do you get the value for the dictionary? What's this indexing? Okay, it's not the number, okay? This is a dictionary. You need to use the key. So you'll be key 3. Okay? So step by step, for list indexing, you use numbers. For dictionary indexing, you use the key. And you get the value. If the value is a nested, it's a list, you get another list. So it can be quite complicated, but look at the upper level first, the hierarchy. So look at the top level first, and then narrow down, narrow down. In reality, we don't really utilize this kind of complicated data structure. But once you understand the logic, you should be able to tackle anyone. You can give me like with 10 nested labels, doesn't matter. I can just step by step, I can get to the information. Okay, so that's all for today. Spend some time on lab 1, and if you have any questions, post on GitHub. Ask ChatGPT as your last resort, okay? Don't dump questions into ChatGPT. I will see you in the next lecture.